Good afternoon, everyone. My name is Robert Hreniewicz. I am the data evangelist at Hortonworks. And my co-speaker today will be Rachel Paulson. She's the director of data science at TiVo. And today we'll be talking about building a graph database, Neo4j with Spark and Spark SQL using log data. Rachel Paulson will give an introduction and a little bit of background. I will jump in with the technical aspects and a little bit and a very quick demo, and then Rachel will close out the presentation. Rachel?
Okay, is this on? Can everybody hear me? All right. So as Robert said, I'm the director of data science at TiVo. I manage the data science team at TiVo, as well as the team at TiVo's subsidiary, TiVo Research. And the data science team at TiVo, we do a lot to help the product team. And at our subsidiary, we do a lot of custom analytics for different networks and brands. And a lot of our projects overlap. And some of the motivation for Neo4j and the path analysis that I'll talk to you about comes from both of those businesses. So I'll give a quick introduction to TiVo and TiVo data and some of the challenges that we face that are going to require something like Neo4j. And then I'll turn the time over to Robert to talk about the solution and the demo. Robert worked with TiVo for a few months as a contractor building this prototype. So very excited to be back working with him and very excited to continue this prototype at TiVo. How many people in this room have a TiVo? Oh, wow. More than I thought. And how many people know what TiVo is? Okay. So TiVo is largely known as a DVR, which is one of the functionalities of TiVo. But over the years, we have evolved into a discovery platform for integrated entertainment. And I think that I do have a little bit of a demo video to show, which I think shows very well what TiVo is. And I will ask that you forgive the marketing department for the choice of music. If you can hear it. Oh, well, we don't have to listen to the music, so that's great. Oh, there it is.
There we go.
There we go. So there are many different ways to find content on TiVo. There's a trending now. There's what's on your cable and what's known as traditional linear TV. There's also, you can watch your content on all of your apps like Amazon and Netflix and Hulu. They have a functionality called One Pass now, which allows you to look at all of your seasons of entertainment for a television show across all your different content providers. So if season 4 of Modern Family is on linear TV and season 3 is on Amazon, you can get it all in the same folder. The DVR functionality, you can record multiple pieces of content at once. And in a minute here, it'll jump in and show you the capabilities to watch your content on the go. So there's apps where you can stream in-home, out-of-home. Make sure I didn't forget anything. We also have suggestions, which is recommended content that we'll use. So here's the stream portion. So we don't have to get too far into this. So there's multiple ways to find content. Where's my mouse? And it's not going back. One moment. There we go. Excellent. So there are multiple ways to find multiple pieces of content. And one of the business questions we had on the product side is how do people get to content? And not only how do they get from A to B to get to that content, but what are all the steps in between? And what are the relevant steps? How can we improve that process to getting to content? TiVo on the data side collects about 2 million logs per day from their set-top boxes. These logs consist of 3 types of event. One is a user action event, which is the user performing an action on the remote, pressing play, pressing select, changing the volume. And then there's something we call TiVo action events, which is the TiVo performing an action that's not necessarily the direct result of a user action, such as the box starting to record content. If I go into my shows content, there may be an event that's logged that is the box fetching all of that content from the server so you can see everything you have, or the box rebooting. So these are TiVo action events. And the third type is an inventory event, which is more of a state of the box than it is an event that gives all the user preferences. So what are all the season passes that the user has on their box? Do they have parental controls turned on and off? So these are all software specific to how the users set up their device. So the important note here and why we needed something like Neo4j is that in the set-top box logs, these events are memoryless, which means that the box can only know at any moment in time what's happening in that moment of time. So when it comes to a path, it doesn't know during a certain event what the history is. However, we get a stream of logs, so we can derive the history in the processing or the data, the query side or the processing side. So a quick example of a path through the TiVo UI. This is the home screen. As you can see, you can get to content through your My Shows, through What to Watch Now. You can search and try to find content. If you go into your My Shows, we have a number of different categories that you can go to. You can just scroll through everything you have. You can go to the TV series, movies, or sports. So there's a couple of different routes here to get to playing content. Once you get into a folder, as you can see, I don't know if you can see very well here, but there's this icon. Oops, switched. We'll go right back. The icon for American Skyper is streaming, so you can get your content over streaming, or the dot is recorded. So again, there's just multiple ways and multiple types of content you can get to. And one of the motivations is the guide and people using the guide to get to content. This is, there's a hypothesis that people don't use the guide as much anymore because it doesn't matter what time your content plays. All that matters is when you will get your content. Everybody only cares about on Netflix, when is the movie going to be available? When will the show start? Not so much between what hours of the day. So some of the business initiatives TiVo had on the product side is, they want to help users get to the content that they want faster. This is very difficult in terms of measuring a KPI because of the way that the logs are structured. We have to find a starting point for looking for content and then an ending point. So we have to start sessionizing these getting to content sessions, and we may be able to calculate the time it takes in that session, but more importantly, we want to help them understand why it takes a long time or why it doesn't take a long time so that they can improve the product. So it's not just about getting from A to B, it's about how you got from A to B. There's also the process of discovering new content, which is a different use case. If I'm discovering content versus I know what content I want to watch, the product team has different objectives for that experience. And finally, that's what's in between. Is the guide an important feature in getting from A to B and getting to content? Is it still being used, and how often? This is also an important question to the TiVo research business, our subsidiary that does some professional services around custom analytics for networks and brands. They have questions about how do people get to our network? How do they get to our brand? Do they use the guide? Should I put an advertisement in the guide? So these are overlapping business questions that we have. So our objective on the data team is we want to do this, what we termed path analysis. So not only do we want to know about getting from A to B, but it's the how, and we want to understand, we want to query that and explore that and understand that without having a set definition. So historically, TiVo had, a traditional data platform. It was sample-based, it was SQL-based, stored in relational databases. We made a lot of decisions about what data to keep on the processing side. And in the last year, we've switched to more Hadoop-based so we can have flexibility. But as you can imagine with a relational database, doing any sort of path analysis, there's a lot of challenges involved. So what we tried in the past in our relational database was to define the steps of a path, and we had to limit that. We had to say we're only going to look at up to a 5-step path. We had to make decisions about these during the processing step. So it really limited us on the analysis, and we weren't able to get very much insight because all of our decisions were made based off of assumptions when we process the data, as opposed to allowing us to explore the data and let the data tell us what people are doing. And that's where some graphical analytics tool came in place, and we looked at Neo4j, and I will turn the time over to Robert to talk about the solution we came up with.
All right. So let's go a little bit about what a graph database is, in this case, using specifically Neo4j. So what distinguishes is that, from a relational database is that, relationships are first-class citizens at this point. You have simple abstractions, and on top of it, you can have, sophisticated models, right? This path analysis. And within the graph, you see, from the graph, from the top node, on one hand, you have the records that are represented as relationships, and on the other hand, you have the nodes. And of course, the relationships organize the nodes, and then both the nodes and relationships have different kinds of properties. So this prototype that I've built over the 3-month period at TiVo, this is just from 1 day of log data. We've basically produced about 57,000 relationships. And those relationships touched a total of 147 nodes. 135 of them were the UI or the screen nodes that Rachel showed you before, and 12 of those are the watch content nodes, or that could be the live content or the recorded content, shows and movies that people would go to. On top of it, we've noticed something that's really exciting. We've reduced the actual data. So the log data for 1 day was over 70 gigabytes of data. Once everything has been processed, this data has been moved down to 35 megabytes. That's over 2,000 times reduction in size. And that's pretty significant and could translate to savings in the near time and definitely in the future. So what you have when you have this TiVo Remote right now, you transition between the different screens and you get to different content. So what we focused on were the screen events, the button presses as events themselves, and the watch content events. And here's how a simple graph would look like. So you would start from the TiVo Central, which is a home screen. And then if you were to say, like, how do I get to live movie content? You could have 2 paths, right? The user could switch to by going directly, by pressing a specific set of buttons and going directly to the live movie node, or they could be going taking a different route. They could be going to a My Shows menu screen and then going to the live node. So you have 2 different paths going about it, and there's more to it because each switch node could have multiple different keys that got the users there. The architecture is relatively simple. When I got there, all these raw logs were already pre-processed and saved in a Parquet file on S3. So my solution started with working with Spark and Spark SQL and ingesting and processing all this data into Neo4j, which is essentially a key document store. And now that this data is there, for example, if we're just looking at 1 day, that's 35 megabytes stored in the database, you can use your browser and via a simple REST server, you do all the queries and pull the data that's stored there with all the 57,000 relationships. So what's captured in the graph? So let's start with the node, the screen, the simplest one. It's just a name and a timestamp. The node with the actual content, the watch content node. That would specify what type it is, whether it's recorded or live, the genre, it could be a TV show or a movie, and then of course a timestamp so we can aggregate all of them and connections, for example, just that one day. And then on the edge, and this is actually the most interesting part, we've spoken quite a bit about it before we made the decision what goes into the edge, was capturing the average time, total number of key presses, and the key sequence. So here's, for example, the user pressed a home screen button, and then maybe a up and down button, and eventually a select a play to actually get to a different screen, to a different node. Then the total number of times this path has been taken, so just how many other users or the same users have taken this exact same path with the same key sequence. And then the unique number, which provides a slightly different metric, how many unique users have actually taken this path. So that it's not just that one user that's been taking this path over and over and generating a huge number of paths. Now we're like, well, this is just unique. It's an edge case, and then we have the unique users. So this is actually what the connection would look like. Again, you got TiVo Central on one hand, you got the live movie watch content node on the other, and then some sample data. For example, 0.4 seconds average time transition between the two nodes. 3 key presses were pressed. The actual keys will be home and down button and a select button. This path has been traversed 50 times, and of those 50 times, 27 were the unique users. Here's a sample of the raw log file. This is how the file would look like that I would actually interact with. You can see how what's the actual transition. So starting with a watch live node, watch movie node, the key that the user would select at this point will be a home screen key, and they would go to the UI, the TiVo Central screen, and then by pressing 3 buttons down, the select and eventually play, they would get to the last node, which is the watch recorded show node. When it's actually filtered, this looks slightly better. Again, it's just going from a live movie via the home key button to the TiVo home screen, then the sequence of down, home, and play button, down, select, and play button, and then eventually the recorded show node. And of course, all of this is for the same day. The algorithm on the very high level is, the first step is to remove the non-screen, the non-watch, and non-key events, because we just focus on the screen, the watch, and the key events. Then you want to sessionize it, make sure that everything's ordered by timestamp. And as you've seen, there's the screen, the watch, and the edges events between them. And there's another thing we came up with. We've noticed that there's some transitions have many, many keys that users press. Just go up and down, left and right, and you can have many, many keys, 20, sometimes even to 100. So we've came up with 2 different ways of storing these key transitions. So if, for example, there's more than 10 keys, you would store it in a compact form. So instead of specifying all the keys that have been pressed, you would say, well, here's the start key. In this case, it will be the TiVo key. And then there's this last key that was pressed before we made the transition. And they just have a number of keys that were pressed in between. So TiVo, some 9 keys, and a select, and that will get you to the next node. And once you have that, then you've got to generate the edge. We've looked at different times, like what is the maximum amount of time we would let user to transition between the different channels. If it takes more than 5 minutes, we were like, well, has the user just been lounging around, eating popcorn, doing something else? Maybe this is not a real transition that we should pay attention to. So for example, in this case, we would limit it to 5 minutes. Anything over 5 minutes, we would just discard this and not create that relationship between the different nodes. And of course, you can change, you can modify and run it depending on who the stakeholder is and what is it that they're interested in. And then eventually you would run into something that says, there's a node X with a start timestamp, there's a node Y with an end time, and then this different set of keys that were pressed between those nodes. So finally, like I mentioned before, it's for each unique node, edge node, which is, you could think of that each node and edge and a node being essentially a hash key and a hash table. For that, because each node is very unique, could have different key presses between them, and then different nodes would have different names. Then on that, you would calculate the average transition time, number of transitions, unique transitions. Again, these will be the unique users that use that path, the total number of keys pressed, and then the key sequence, whether it would be the normal, the uncompressed, or the more compact form of the key presses. And then, of course, finally, to ingest that into Neo4j, you export it, and that will be saved as a CSV file. So now let's go quickly over a short demo. Let's see if I can actually need to exit this. All right, exit this as well. All right, and there we go. So I prepared a few queries. How does that look like? Okay. So out of curiosity, how many of you have played with a graph database before? Also quite a few of you. All right, I would say a little bit more than half of the room. Let's see. Maybe go back here. So let's just start with, for those of you who haven't, let's just look at the node. So if I was to execute this as a simple node, here's the type of information. So this is a UI or screen watch node. And you can see there's, all that I'm storing here is the name, in this case, a wish list created overlay type node. And some very basic information. There's the year, there's the day, and the month of that node. So now for something more complicated, let's just go for a node, for two nodes, and a relationship. So before I go, the way I use specifically in Neo4j, make sure you can actually see all this. All right. So you have your node, the beginning node that you would specify. Then you have R or any letter for relationship. And then again, you would specify the end node. So here we're not specifying any types of nodes. So basically give us any kind of nodes and relationship between them. And we limit it to one. So now you can see basically we have two different screen nodes. Again, the wish list created node with a key switching to another 3CMS screen node. These are TiVo specific, but there's over 137 of them, so I'm not going to go into what each of them does. And here's the most interesting part is the actual key path that's been generated, right? So you have, how many keys have been pressed. So you have this information, okay, three keys have been pressed for this specific transition. The average time is about 14 seconds. And the key path is someone pressed the TiVo Remote key up twice, and then the TV key right once to actually make that transition. Let me grab another one. So if we run this one. So here's a little bit more information, and I have been a little bit more specific. So for the query, I'm specifying, well, this time around, I would like to go from a UI or a screen node to a watch node, and I'm not specifying which one exactly, and then give me about 10 relationships and 10 nodes total. So now, as you can see, there's much more, many more connections, and I could have, trust me, there's 57,000 of them, so you don't want to see all of them. But again, you have different transitions, and essentially what it's showing are different paths of getting to this recorded content from these different UI or screen nodes. So this way you can start kind of visualizing and exploring as you focus on certain paths. You can be like, what are the different paths? And you can start limiting them and making some specific guesses and theories and hypotheses about what's going on. So a slightly more interesting one. So now we're trying to ask a specific question of, what is a specific intermediate screen node between a UI TiVo Central screen node and a live content or with a genre being a show itself. And with that, you have, and we're limiting just to 5, right? We're limiting, so these are some intermediate nodes. So for example, if you want to find out like how do users get to content and what is, one of the more popular nodes in between them, then you have this list. And now you can start looking like, okay, so here's some additional insight that I'm going to have on how users are actually accessing and how users are going to that path. This one is even more interesting. So now, let's ask a specific question. Like Rachel mentioned, like what is the percentage of paths that actually contain the guide or the screen node? And this would arise, be like, is the guide screen actually used often enough? Are people actually using guide to get to that content? And if we look at it, only 2% of the time for all the paths that the users go, that the guide screen is used. So that means there's a lot of power users that are going from, from a specific screen node to a watch node. And in this case, there could be some business decision that would be used based on that very simple and powerful information. So finally, for this demo, what is the most popular path? And this one runs a little bit longer. I've still limited to only up to 2, because as you increase, there's more paths and you need more powerful machines. So on my one node machine, this would take quite a while. But essentially going from, from a UI or screen node to a watch node, being more specific this time around, starting from a TiVo central screen, the main screen, and then ending at, a live movie node. And we're just making count. So as you can see, the most popular path at almost 270,000 total is going from TiVo central screen via an episode live watch node to finally a movie node. And then the second on top would be about 80,000 of them, and then going from TiVo central screen again. So these nodes can loop to itself, right? So users can have a certain sequence and then end up again at the screen. So it's including all of these, right? So self-referencing nodes, if you will. And then you can keep scrolling. I'm just limiting to 5. And this is the kind of information we could evaluate. So what are different paths? What paths might not be as relevant? And then based on that, you can make some additional decisions like, well, maybe we should change our menu, or we should modify the remote control. So let's go back to the presentation. That's all for my demo. All right. So some additional questions, right? And we're just not going to demo it here at this point. It's like, so again, like what is the most popular path? Live versus recorded, right? What is the percentage of total paths and which ones are most popular? The unique versus the overall. Apps which are more popular, which is like, you could have Netflix or Amazon or Hulu apps, and then which ones are most popular? Which ones, how do users get there? And that's the kind of insight that now, having all this data in a graph database, you can have and extrapolate. And of course, like I've showed you, what is the percentage of total path that involve the guide screen in this case. So the power of this is, that now you give this tool to data analysts and they can write queries. So you just run it, a multi-day, a whole year, multi-year, and now they can query and see how these things change based on the users, whether these are new users, old users, power users, users that are just plain lazy. And with this kind of information, you can make additional insight. And with that, Rachel, I hand it back to you.
So this prototype only considered the live versus recorded TV. We do want to add in apps and launching apps, which is fairly easy once we have the underlying framework to add an app and launching an app an end node, just like the watch content nodes. Robert's really helped build the framework for this in order for us to move forward with the path analysis that we're looking for. So some of the business advantages, just looping back into what we talked about at the start, is not only the capability to measure this KPI of time it takes the user to get to content, but understanding how they get to content. So you can give the stakeholders their KPIs that they're looking for, and then you can also give them insight into how to improve those KPIs. This will also enhance any A/B testing capabilities to help answer these why questions or these how questions, and seeing, if we take the guide away from one type of user, how is that going to change their path? It allows us to simplify the user experience. I think that's one of the most obvious ones within the UI, and simplifying these paths. Increasing engagement, and understanding this feature usage. So that's something else we want to add in. We talked about guide as a way to get to content, but there are other features like search that allow users to get to content, or wish lists, or other TiVo-specific features. So understanding not only if these features are used, but are they used in finding content? So something, for example, such as a wish list, a lot of TiVo users may set up a wish list search, may not finalize that search, but may use it to find content. So a wish list it's an advanced search that a TiVo user can put in, and the TiVo will automatically record, say, all comedy movies if you wanted a wish list search for comedy movies. But you don't have to get to that point where you are actually using the capability to record. You can just use it to find content. So that's another way we can understand how features are used. So our future work is to deploy this into production. It's just a prototype right now, so we want to be able to run multi-day queries, see how these paths change over time, adding in more relationships and nodes for feature usage, and also start to do some machine learning or some statistics on top of the data to classify these paths. You know, is this a discovery path, or is this a path where people are getting to a known destination? They know what they want to find. And of course, exploratory analysis. So with that, I will open it up for any questions. Yes?
So you mentioned that you already have Spark in your ecosystem, and you apply Spark SQL for some pre-processing prior to putting data in Neo4j. You do have an option of using Spark graphics or graph frames instead of paying the survey cost and data movement cost between two different systems. So have you tried using that option if you have some insights, or do you wish to go that path?
Yeah, I mean, that's a good point. So just to restate the question, we already have Spark in our ecosystem, and Spark does have some graphical analysis tools. And the reason why we went with Neo4j at the time, the platform was very young, and we were just in development, trying to figure out what we wanted to use. Spark was one of those that we hadn't solidified yet, but we were playing around with. And so Neo4j as well, since we hadn't signed up with any enterprise software. So there wasn't too much, at this point, since it's still a prototype, there hasn't been too much thought into which graphical analysis tool we want to use. The question we want to answer for the product team right now is why a graphical analytics tool would be very valuable, and trying to get the stakeholders to invest in it. So we may switch away from Neo4j if it makes sense. Any other questions? And for Robert as well. Yes?
Why Neo4j? Why not?
I'll let, I asked Robert to explore some graphical analytics tools.
At the time while we've spoken, so part of the product team, they've read about Neo4j, and it was really a simple decision that we found that there was already powerful integrated environment from the get-go, and we've explored. We really like the Cypher syntax, or I would say I really like the Cypher syntax, so I had a lot of influence in convincing everybody there and showing the product team and Rachel getting things out what we could do very easily. This also involved us being able to convince other stakeholders and get them excited about this product as well. So that was the major reason. The ease of use, the ease of having data analysts at TiVo just run with the queries, and it seemed like a very stable development environment at the time.
Since you mentioned you use Spark and Spark SQL to grab the data, why not SparkX or the graphics? Spark?
So in this case, it was the structure of the logs themselves, yeah, and then putting them into data frames, and then using the Catalyst optimizer underneath to actually execute this very quickly.
And part of the objective, too, when Robert came in, was to get executive buy-in for a graph analytics tool. So in terms of deploying this and moving this into production, we are going to have to ask a lot of those more technical questions with the data engineering team and the operations team around what makes sense. And we already have a prototype in Neo4j, so if that makes sense, or since we're using Spark, should we move to graphics? Yes?
What's your strategy for multi-day queries? That seems like a totally different problem.
Yeah, I mean, ask you to expand on that because I feel like the multi-day queries, I mean, we just have a list of timestamps. So at some point in the query, we've got to say what the start and end is. Right now, the start and end is just happens to be the day that we have.
I guess I was asking if you're processing a day at a time, would you process all your data and let people interactively take time slices of it?
Oh, sure. Yeah, I mean, we will probably have a lag for when people can query from it. We process a day at a time, but then we allow for reporting and analytics is about 3 days behind. Yes?
Are you able to select a time range and do this type of analysis, or are you limited to only looking at a day?
I think so. Right now we're scanning over everything because we don't need to limit it.
But if you had made some improvements over a period of time, you want to be able to see if that has changed the user behavior.
I think the Cypher language allows for us to select a time frame. It would depend on how we stored it.
Right. So right now we just have the day timestamp, right? If we had more resolution, then we could yes. So to answer your question, if we had more resolution as far as like the timestamp information, then we could query like at what different times of the day. And that's actually something that's also very valuable.
Yeah.
So we could see spikes, or we could set different paths, or maybe it's late at night versus early in the morning versus afternoon, and that's additional insight that we could extract from that.
I think from an analytics perspective, I might want to first classify them as what type of path it is, and then see if there's a peak in the type of path. You know, is there more discovery? Is there more guide utilized path search at a certain time of the day? Yeah.
Hi, you might have answered this before, I don't know, I didn't hear it, but how did you actually use Spark SQL in this analysis? I didn't actually catch that.
So the Spark SQL wasn't used in the analysis. The Spark SQL was used to quickly build the relationship between the different nodes. So once I had a session for a specific user, how they went between the different nodes and which keys they pressed, then I could generate, so each node plus the key presses and the end node, that would be like a unique key. And based on that, I could aggregate everyone. And Spark SQL was really efficient in that with having, with data frames and the catalyst optimizer underneath.
Okay, thank you.
You're welcome.
All right. We'll take one more question. I know you're all probably anxious to get to lunch. So.
Yeah.
Yeah.
Can you describe what the data model is for a graph database in terms of, you said it was a key value document store, but what makes it performant? Where does it place the data, memory, disk, those relationships?
That would be, that's a little bit beyond. That's something that I haven't explored as much as far as like what is the underlying performance for this key document, right? We just went with it, and it satisfied our needs currently. We haven't done an exhaustive evaluation of other storage layers and other graph databases to the point where it could be like, well, this one's actually more efficient for the type of queries we do versus all the others. So we haven't focused at all in the sense of, would this be performant in this, monthly, yearly type of queries where you have this massive type of data. Right now, for this prototype, this was sufficient. It was fast enough for the type of queries we wanted to evaluate.
Okay. Thank you, everyone.
Thank you.